All right, today we're going to be talking about modeling with exponentials. You do have a quiz, so make sure you study for it. Compound interest. The formula is A equals P times 1 plus R over N to the NT power, where A is the amount in the account after T years, P is the initial amount in the account, and initial means how much you're investing. R equals the interest rate written as a decimal. N equals the number of times interest is compounded per year, and T equals the number of years. And please make sure you're putting this in your notes. If that means you have to pause the video, please do so. All right, so the number of times it compounds per year. If it says it's compounding annually, that's 1 time. If it says it's compounding semi-annually, that's 2 times. If it says it's compounding quarterly, that's 4 times. If it says it's compounding monthly, 12 times. And compounding daily is 365. So, you need to know those values. If $10,000 is invested at an interest rate of 10% per year, compounded semi-annually, find the value of the investment after 5 years. And because it said it's compounded and then it gives me an amount of time, then I know I'm going to have to use compound interest. So that's A equals P times 1 plus R over N to the NT power. Now let's see what we know. I know P. P is the amount of money I invested. I invested $10,000. I know R. R is the interest rate written as a decimal. Well, to turn it into a decimal, you can either write 10 and put a decimal behind and move it to the left twice, or you can say 10 divided by 100. Either way, that gives you R equaling 0.1. Then I need to know N. N is the number of times it's compounded per year. And as you see in your chart above, if it's compounded semi-annually, that means 2. And then T is time, and time is 5. So, now I'm ready to plug in everything. A equals P, which is 10,000, times 1 plus R over N, so that's 0.1 divided by 2, to the NT power. Well, N is 2, and T is 5, so you have 2 times 5. Well, we all know what 2 times 5 is. 2 times 5 is 10. So I just write 10. Now this is ready to go in my calculator. All my variables are on the left side, so I'm ready to solve. I just type it in. 10,000 times 1 plus 0.1 divided by 2 to the 10th power, and that gives you $16,288.95. $16,288.95. Because we're talking money, we're going to be rounding to 2 decimal places. All right, next example. My next example says a man invests $6,500 in an account that pays 6% interest per year compounded monthly. My first question says how much is the investment worth after 2 years, and my second question says how long will it take the investment to double. So I'm going to do question 1 first in black, and then I'll do question 2 in a different color when I'm finished with question 1. All right, so it says it's compounded monthly, so it gives me a specific time. So that's A equals P times 1 plus R over N to the NT power. And you need to write what you know. You know how much you invested. You invested $6,500. You know your interest rate. It's 6, but you have to turn that into a decimal. So that gives you 0.06. And you can slow down the speed of my video if I'm going too quickly for you. N equals the number of times compounded per year, and compounded monthly. There's 12 months in a year, and then T is time. And it says 2 years. I plug in everything I know. A equals your investment times 1 plus your rate divided by the number of times compounded to the nt power. Well, n is 12 times t, which is 2, and we all know that 12 times 2 is 24. And now you're ready to type it in your calculator. So, 6,500 times 1 plus 0.06 divided by 12 to the 24th power. And you get $7,326. And 54 cents. So that's when interest is compounded in a specific amount. Now I'm talking about continuously compounded interest. If it's compounded continuously, and it will say the word continuous. Oh, I'm sorry, I forgot to answer the second question in the previous example. I need to do that. So I'm erasing this, and I'm going to answer the second part. My bad. All right. Okay. I'll do that one. All right, so still is A equals P times 1 plus R over N to the NT power. And we need to write down what we know. How long will it take the investment to double? I still know that P is 6,500. I still know that R is going to be 0.06. I still know it's compounded monthly. But now I know A. I want to know how long it takes for it to double. So I know the amount. 6,500 doubled is $1,300. So I want to know how long it'll take to be $1,300. Not 1,300. I think I meant to say $13,000. $13,000. And I don't know T this time. I'm asking you how long, so you don't know how long. So plug in everything you know. You know A is 13,000. You know P is 6,500. All right, and I need to solve this equation. The first thing I need to do is get the exponential expression by itself. So I need to divide by 6,500 on both sides. Well, 13,000 divided by 6,500 is 2. And I need to go ahead and simplify what's in that parentheses. So I'm going to say 1 plus 0.06 divided by 12. And that gives me 1.005. And that is raised to the 12t power. But when you need to get something out, when you need to get a variable out of the exponent, you have to introduce a logarithm. So 12t becomes the coefficient log of 1.005. This is old news. You've done this before. If you put a log on the right and you must put one on the left, you are trying to get t all by itself. You have a 12 and a log of 1.005 connected. You can divide them both out at the same time, and it cancels, and you're left with t. Log 2 divided by 12 log of 1.005, and now it's ready to go in the calculator. Log 2, close parentheses, open them, divided by 12, log of 1.005, and you get 11.58 years. So if you wanted to invest some money and you want to know how long it would take to double, this is what you would do. All right, new formula. Continuously compounded interest. A equals PE to the RT. The letters mean the same as the formula above. So A is still your final amount, P is still your initial amount, E has its own value, and R is still the rate, and T is still time. Everything's the same. So Sue invests $10,000 in an account that pays 8.5% interest per year compounded continuously. That's how I know to use the continuous interest formula, because it has the word continuous in it. How long will it take the account, first question, what is the value of her investment after 10 years, and how long will it take the account to be worth $50,000? So I have two questions. I'm going to do the first one in red and the second one in a different color. So do it in one. Because it says compounded continuously, I know this is my formula, and that will not be provided on your final exam, so I expect you to memorize it. All right, your initial investment is $10,000. Your rate is 8.5, but 8.5 written as a decimal is over twice, 0.085. Then we need to know the time. The first question says 10. So I'm plugging in everything I know. A equals 10,000. E to the RT power, so 0.085 times 10. I suggest that you go ahead and figure out what 0.085 times 10 is. Otherwise, it makes your problem messy. 0.085 times 10 is 0.85. Now you're ready to put in the calculator. You don't have any variables over there anymore. So plug it in. 10, 1, 2, 3, E to the 0.85. And you get 23,396. And 47 cents. All right. Now I need to answer question 2. I'm doing question 2 in blue. All right, question 2 says, how long will it take the account to be worth 50,000? Well, it's still A equals PE to the RT. Only this time I know A, it's 50,000. I know R is still 0.085. I don't know T. And I know P is 10,000. And I plug everything in. A is 50,000. P is 10,000. E to the RT, so 0.085 T. You need to get E by itself before you can solve this, so you have to divide by 10,000 on both sides. So that gives you 50,000 divided by 10,000 is 5. You need to get that variable out of the exponent, and to do that, you have to introduce a logarithm. Because it's an E, you introduce a natural log. And you do not have to write the natural log of E because it cancels out. Now all you have to do is divide by 0.85 to get T by itself. So, natural log 5 divided by 0.085 and 18.93 years is the answer. One more example and then I'll be done. Actually, I'll save this one for class. If you could just have the formula written down, that way my video won't go over 15 minutes. So please have this video, please have that formula written, and we will do an example when you get here.